Hey class, welcome back to the channel. So today's topic is about we are going to discuss types of reaction or types of chemical reaction as you can see in the paper. Clear? In the last couple of classes we have discussed about the introduction part of chemical reaction and equation and how to make the balancing part of the chemical reaction. So without wasting any time, let's begin today's class. So today's topic is about types of chemical reaction. And the first topic is about combination reaction. In the name itself, it says thus combination. That means to combine something. So when we talk about combination reaction, make sure the definition part. A combination reaction is a chemical process where two or more reactants, that reactants could be your elements or even compounds, and when they combine together to form a single new product, then only you can say that is a combination reaction. So for example, let me show you. If you are talking about A is one your substance, B is another your substance, it gives rise to AB. So this is called combination reaction. And this A or B could be your element, could be your compound. We have no objection, but the outer product should be only one. Then only the reaction is called as combination reaction. Hope you understand. Now proceed forward. And particularly these reactions are called synthesis reaction. Synthesis means only combination or combine something. And frequently and oftenly people used to call it exothermic. What's called exothermic? Let me tell you. Exo means release and thermic means heat. That means during the chemical reaction, heat is released. So in combination reaction, heat is released. So that's what is called as exothermic reactions. Clear? And most importantly, it is the opposite of decomposition reaction, which we are going to discuss in the next segment, that is decomposition reaction. And this is the exact opposite of combination reaction. I hope this is clear. Now let us go through some of the examples. Burning of coal. Because as we know that in coal, carbon is there. Clear? And for burning, which gas essential? Oxygen. And after burning, usually carbon products gives rise to carbon dioxide. So can we say that carbon plus oxygen, two reactants combine together to form a single product? That belongs to combination reaction. And the last step of every chemical reaction is need to be balanced. So here one carbon, two oxygen. It is already balanced. Now to make authentic this reaction, carbon dioxide is released in the form of gas. I hope this is clear. Another one, formation of water. Since hydrogen is a gas and oxygen is also a gas, but when these two gases are combined together, their chemical identity or chemical properties is totally different or totally changed to make it water. And the formula goes H2O. And the state will be your liquid. The last step will be balancing part. And the balancing part goes like this. H2, O2, but here it is O1. To make it authentic or make it balanced, we need to multiply 2 in the product side. And ultimately, how many hydrogen is there? 4 hydrogen. Simply multiply 2 it here. Now this reaction is perfectly balanced. Now moving forward. Okay. Now another example I have written, formation of slaked lime. And slaked lime of usually basically known as calcium hydroxide. What's called? Calcium hydroxide. Calcium oxide plus water gives rise to calcium hydroxide. And the formula goes CaOH whole twice. And usually this reaction is highly exothermic. So you may write plus heat. Last step again need to be balanced. Here one calcium, two oxygen. It is already 2 oxygen, 2 hydrogen and 2 hydrogen. This is okay. Now bonding of magnesium ribbon. Magnesium ribbon means only simply magnesium metal. Clear? And whenever any metal reacts with oxygen, they gives rise to metal oxide. And the metal oxide means magnesium oxide. And the formula goes MgO. The last step, you need to balance again. 2 oxygen, 1 oxygen. Simply multiply 2 here. Now ultimately 2 magnesium. And the left side should be 2 magnesium. I hope the chemical reaction starting part or the starting step, combination reaction has been accomplished. Now moving forward, decomposition reaction. Clear? Let's go to decomposition reaction. And let me tell you, dear student, this is the exact opposite of combination reaction. Because as we know that in combination reaction, one or two, even two or more substances combine, they gives rise to single product. But in decomposition reaction, a single substance, and particularly it's supposed to be a compound, let me tell you, and it should breaks down in the presence of energy. Because to break something in chemistry, we must require some amount of energy. And after breaking the compound, we may get new simpler substances. I hope this is clear. Now coming to the definition part. A single reactant or reactants particularly breaks down into two or more simpler products and usually requiring energy, particularly because if you want to break something, some amount of energy must be required, and that energy could be in the form of your heat, could be form in the of light, or even electricity. And generally it is endothermic by nature. If you remember, we discussed about it. Frequently combination reactions are exothermic since they are releasing the heat. So similarly, and your decomposition reaction are your endothermic. Endo means particularly heat should be required, or energy should be required, or energy should be gained. Clear about this point? Okay. And it can be categorized as thermal, electrolytic, photolytic. There are three variations of decomposition reaction you are going to study in this session. Okay. Now this is the actual pattern as I was talking about it. AB gives rise to A plus B. Since above the arrow mark, you must apply some amount of energy. Again, I am repeating that energy could be your thermal, electrolytic, or photolytic. Thermal means simply you have to heat the substance, like in the presence of burner or gas, anything. Electrolytic means you have to break the substance by applying electric current. And photolytic means simply in the presence of sunlight, if something breaks down, that is called photolytic. So step by step, let's proceed. Let's go with thermal decomposition reaction. And thermal decomposition reaction is also known as thermolysis. Thermolysis. Let me tell you, thermo means actually heat, and lysis means breaks down in chemistry. I hope this is clear. That means by applying heat, if something gets breaks down, that is called thermolysis. So some of the couple of reactions as I hear according to NCERT. FeSO4. The actual color of this particular compound is green. Okay. And also after completion of this chapter, I'm going to provide some of the charts of a reactions where you can see the color of these compounds. But that is beyond the concept. Now focus to this one. FeSO4. Clear? It's a metal sulfate. And whenever ferrous sulfate or any kind of metal sulfate breaks down, they undergoes thermolysis, and particularly they produce metal oxide. And iron its oxide means the formula goes Fe2O3. Since sulfate is there, that's why there are two types of sulfur oxide can be produced. They have the chances. One is your SO2 and another one is your SO3. Sir, is it necessary to mention SO2 and SO3? Exactly. If you are unable to mention SO2 for balancing purpose, you may mention SO3. But as per class 10th, it is strictly written in the NCERT book SO2 and SO3. This is basically two different gases of sulfur, and they release with a pungent smell. Pungent smell means a rotten egg type smell. Clear? Now the last step again, balancing. 2 iron, simply multiply 2 iron. Now it is already balanced, I think. 2 sulfur, here it is 1 in the product side. 4 2s are 8 oxygen, and the right side 3 plus 2 5 plus 3, that is 8. Clear? Now coming to another example. Calcium carbonate. Can I say calcium is the metal at here? And when a metal carbonate breaks down, it gives rise to metal oxide, and the metal oxide goes calcium oxide, CaO, and releasing of carbon dioxide, and that should be released in the form of gas. Again the last step, balancing. 1 calcium, 1 calcium, 1 carbon, 3 oxygen. Here it is 1 plus 2, that is 3, already balanced. And this is your highly essential, the last example of thermal decomposition as per class 10 syllabus, lead nitrate. Lead nitrate, why it is essential? Because usually this question has been asked the last couple of 5 to 7 years. And whenever metal nitrate breaks down, it forms its metal oxide. Metal oxide goes lead oxide. Along with that, nitrogen oxide, and which is actually brown fumes, or the color I may write it here, the color goes brown color. Along with that, some amount of oxygen gas is also released. Last step again, balancing part. Clear? So one lead, okay, fine. Two nitrogen, here it is only one nitrogen. 1, 2, 3 plus 2, 5 oxygen. Here it is 3 to the 6 oxygen. So when you are going to see that any kind of even or number, simply try to multiply by the number 2 at least, because nothing is present means what is there? 1 is there. So at least the second number after 1, that is 2. Clear? Now it becomes how many lead? 2 lead. Here also 2 lead. Now 2 to the 4 nitrogen. Simply here it is 4 nitrogen. Now check basically the oxygen part. 3 to the 6, 6 to the 12. And the product side, 2 oxygen, 4 to the 8, 8 plus 2, 10, 10 plus 2, 12 oxygen. Now it is already balanced. Again, I'm telling, if you are unable to understand, go through this video again for this particular reaction. This is highly essential. Now coming to second category of decomposition, that is electrolytic decomposition reaction, which is also known as electrolysis. Again, I'm telling, electro means electric current and lysis means breaks down. That means this kind of reactions that use electric current or electricity to break down a compounds. You must remember, dear student, if you are applying electrolytic decomposition reaction or electrolysis, the bond should be that much strong. So that's why you are going to apply electric current. Otherwise, things are not ready to break down. So water is one of the most common example according to class 10 syllabus, and of course you are going to study in the higher classes. This particular bond will break down in the presence of electric current or electricity, and H2O breaks down to form H2 plus O2. The last step again, balancing. 2 hydrogen, 1 oxygen, 2 oxygen. Can I multiply 2 at here? Now ultimately how many hydrogen? 4 hydrogen. Here also 4 hydrogen. Second one, NaCl. And as we know that during electrolysis process, if sodium chloride breaks down, it forms Na plus and Cl minus, since it is a electrolysis process. I hope this is clear. And this kind of reactions comes under electrolytic decomposition reaction. Okay, now coming to photolytic decomposition reaction. Highly essential. Usually two reactions are there in class 10. Let me tell you. Photolysis means in the presence of sunlight. Simply, I have mentioned it here, sunlight. Simply, if you keep any compound in sunlight, if they undergoes to separate by themselves, that is called photolytic decomposition reaction. And one of the compound example I have taken, silver chloride. And silver is the metal, one of the least reactive metal. And silver chloride, which is actually white in color, and the state basically solid, if you take in the presence of sunlight, in the place of sunlight, you may write UV. UV means ultraviolet, which is actually sunlight. And it will separate silver plus chlorine. And chlorine will be released in the form of gas. The last step again, balancing. Silver, silver, 1 chlorine, 2 chlorine. Simply multiply 2 here, and it becomes 2 silver. So that's why this side also 2 silver. And highly essential 1 mark question is basically from this reaction. The uses of this reaction is for purpose of photography. I repeat, is purpose for photography. Clear? But so far we have discussed about thermal decomposition, electrolytic decomposition and photolytic decomposition. Remember, dear students, when we talk about this kind of decomposition reaction, students are actually unaware in which decomposition reaction actually belongs to which category. That means NaCl belongs to electrolytic or photolytic or thermolytic. So to remember this concept even better, I have made some note like kind of tactics to make it authentic and precise about your board examination. Let's go through this process step by step. Usually top reactive elements means particularly I'm talking about metals. From their compounds, they breaks down by electrolysis. If you talk about the top reactive elements, top reactive means for this purpose you have to remember the reactivity series. And reactivity series I am going to discuss in the next segment, that is single displacement reaction. So you have to be wait for this particular video. So till then you have to watch it particularly. Okay. Now this is the conclusion part. Okay. So usually moderate reactive elements, from their carbonate or nitrate or sulfate or any kind of oxides, they breaks down by the process thermolysis. These are talking about medium reactive or moderate reactive elements. And usually least reactive elements or the least reactive metals, particularly silver, gold, platinum, they breaks down by the process of photolysis. Clear? And for your syllabus, one of the exceptional case, it is not exceptional, but to remember it, I have written as exceptional. Water breaks down by electrolysis, as I already mentioned. And thank you for watching, and I hope you like this video, and still wait for the next upcoming videos for the upcoming session of different type of reactions. Thank you.